Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss other question on adiabatic expansion. A gas sample containing 6 mole of hydrogen gas undergo adiabatic expansion, dropping its temperature from 300 Kelvin to 275 Kelvin. Compute the work done in joule given that the adiabatic index is 1.41. Alright, so since in the question it states here that it does undergo adiabatic expansion, so the formula that we are going to use is W, which is for work, is equivalent to NR divided by the adiabatic index minus 1 times T1 minus T2. Alright, so your W is the one that you want to calculate. So in the question it states that it's 6 mole. So 6 mole times R, which is the gas constant, 0.0821 liter atmosphere mole Kelvin. And then your adiabatic index is 1.41 minus 1. Your T1 is 300 Kelvin minus your T2 is 275 Kelvin. Therefore, you will get your W. So first, we need to slash out the unit first. So all the Kelvin, you can slash this out. And this one is mole. So this one can slash this out as well. And then that's about it. So your W should be equivalent to 30.037 liter atmosphere. So bear in mind that when you are calculating work, the unit should be always in joule. So 1 liter atmosphere is equivalent to 101.3 joule. Therefore, since you have 30.037 liter atmosphere, just have to times 101.3 times the same value. So you should get 3.0427 times 10 to the power of 3 joule. So this is the final answer for this question. Thank you so much for watching this video from the beginning to the end. So I'll see you again in the next video. Goodbye.